All right, so what we're going to do today, what we're going to do now, is I want you to be able to write, and this will be a good review for people who are watching. The final orbital suborbital is next. We did the long form, we did the short form, and I think I did EC, Electron Configuration. That's the title of the videos that I put on yesterday. It says EC5, Roman numeral 5, and then yesterday's date. You see that?
Yes.
Okay, that's what I'm going to do now. So, you have the electron configuration, right? Now, remember we did this. We did this one. What was the last entry for that? What was the last term for that? 118, do you remember? It was 2, 3, 4, 5, 6, 7. It was 7p6, right? So what I call, this is like a Darcyism, what I call final orbital suborbital. Final orbital suborbital. Yes? I have they were here yesterday, so they have no idea what I'm talking about relative to final orbital suborbital. If you look at the lecture on electron configurations, it'll all be very clear to you. It's very well done, by the way, if I do say so myself. Okay? Okay? Got it? Yeah. So, the final orbital suborbital, in other words, the final entry for this would be 7p6, right? What's the final orbital suborbital for this? Let's check a few of these. Let's go there, 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 and there. Okay? So what's this one here? Good. Good. 2, right? Right? You want to make fun of my 2 back there? Okay, all right. You know, my feelings were hurt, though, you know. You know, the first time I got detention was in first grade because they didn't like the way I got made a 7. Mrs. Laurie. They didn't like the way I made a 7. Can you imagine? I had to stay after school because she didn't like the way I made 7s. I made them like this. A little cross there.
I do that too.
Yeah, I'm like, I don't know why. My grandfather did it or something. I don't know. But she didn't like it and I refused to change. So anyway, what's this one?
7.
Nope.
4 of 1.
6.
Right? You get it or no? 3, 4, 5, 6. Right?
Yes.
What's this one?
4.
Good.
D4.
You got to be able to count. That's important. Okay? No, I'm serious. I mean, counting is, you know, that's the most complex math skill here is counting. Yes? Okay? Adding if you want to add up the total electrons. What about this one?
61. 5.
Yeah, because it's going to be 2, 3, 4, 5, 6, right? Have you noticed that the S and the P's are at the same level? 6S, 6P. That's going to be important when we do bonding. What's this one?
4P3.
Who said that? Well done. How about this one?
2P6.
Yeah. So you have to be able to do the final orbital suborbital. That's pretty easy, right? Yes? Now, the next horror shock is going to be quantum numbers. I know it sounds very like who cares, like, but it's very easy, and it's a way of mapping the periodic table, and it's a way to see patterns within the periodic table. That's why I like to do it. It gives you more of an appreciation for how the periodic table is put together and the patterns which exist in the periodic table. If you can identify patterns, Ella, right? you can possibly predict the way elements will react to each other. You might be able to predict the physical properties one element has relative to another based on its position in the periodic table and what surrounds it. Whether or not something's a gas or a solid. Yes? So let's do quantum numbers. The first quantum number is easy. The first one is easy. And that's going to be n. The principal quantum number. That's the energy levels. That's the principal quantum number. So if I write 6s2, what's the principal quantum number for 6s2? What's the energy level? 6, right? 2 is the number of electrons, right? It's this electron, it's that last electron you put in. That's what you write the 4 quantum numbers for. But it's going to be, isn't the energy level going to be 6? Isn't it?
Yes.
Do you remember we said that, the principal quantum number, right? We call it n. Remember we said that that's going to become very important? I said that earlier in the period. Okay? So the next one is called the shape. And that's going to be S is 0, P is 1, D is 2, and F is 3. Yes? So what's going to be the shape quantum number for 6s2? 0. Make sense? Yes or no? Yes? Okay. The third quantum number, m, magnetic or orientation, m, is going to be, can I use these squares for something other than elements? I want to make a chart. Is that okay? Yes? Okay. So I'm going to make, these are orbitals. Okay? This is going to be S, P, D, F, right? Yes or no?
Yes.
So that's going to be S, okay? Are you all right with that? Yeah. All right, now, these values, I can make these dotted lines, okay? And these are kind of like on a number line, these orientations. For instance, you see how you have a middle, right? Then you have 1, 2, 3 to the right, 1, 2, 3 to the left. You see that? Red? Red, red? I don't know, just pick one. You both get it? Does red and red get it?
Yeah.
Thank you. Well done. Nice touch, coach. Okay, so this is going to be 0, plus 1, plus 2, plus 3. See how I have the plus sign there? That's important. This will be minus 1, minus 2, minus 3. Is that okay? Is that okay? Now, when you fill these with electrons, you half fill and then you all fill. What does that mean? What does that mean? All right, now you got that? I'm going to erase that. Okay, is that all right? That's been documented, it's on the board. Yes?
Yes.
Okay. So what I'm going to do is I'm going to erase this. And I'm going to say, let me do a D. D is easier to explain. That's D, right? Let's pick this element here. All right? So, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 9. It's going to be 3, 4, 5, 6, D9. Is that okay? So what you do, the first thing you do is you say 6D9. You write down the NLX, or the final orbital suborbital, right? Now, you have to put, these are little spheres that can contain 2 electrons, correct? Yes? So I can put 10 in here, right? Well, this is how you fill. You fill like this. You put in half, and then you put in the others. We got to put in 9, right? 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 Is that right? What's wrong with that? I put in 10. So that's where it is. What's the position, what's the orientation, gentlemen, of that orbital in terms of M? You remember? I had the numbers on the board. What's your ability to recall? Remember I had the numbers like this?
1.
No?
Plus 1.
Wasn't it plus 1? Who said plus 1? Yeah, you're right. I'm sorry. I was thinking it was an F. You're right. I'm sorry. My apologies. Yeah, it's going to be plus 1 because you're looking at that last electron you put in. Okay? What electron are you looking at? You're looking at the last one you put in. You get that? So the M is plus 1. So your choices for, I'm going to erase this. Your choices are because other elements will be discovered. That's what the ... is, or as they say, the plot thickens. Okay? You have -3, -2, -1, 0, +1, +2, +3. Okay? You get it?
Yes.
Now, the easiest quantum number is something we agree on as a class. Clear? And that's called S. The spin. This is called N, L, M, S. Spin. +1/2, -1/2. Now, this is what we agree on in the class. If the last electron that you put in is alone, it's just a single electron, then the spin is +1/2. If the second electron that you put in is the second electron, if the final electron you put in is the second electron, then it's -1/2. Clear? Yes? Let's do 6D9 again. Okay? So it looked like this. So it's right here, right? So what is that a full? Is that full? So what would it be? +1/2 or -1/2? It would be -1/2. Do you see that? You see? So this is what you do now. So you remember it was -1/2, right? So this is what you do. we were here. Okay? You write a little plus sign, right? And you say, I'll use different colors. I'll use 4 colors. Okay? We'll use black for N. Okay? What's the N for this electron, 6d9? What's the N? 6, right? Right? What's the shape? What's the L? For 6d9. Who said that? Somebody said the right answer. Who said it? Red, you say it? Right?
Yes.
Correct? Right? D is 2. All right, what about the magnetic? What about the orientation one?
Plus 2. No.
It's +1, remember? And what about the spin?
It's minus 1.
That's it. Quantum numbers. Not bad. You got to practice. I mean, you know, I just gave you a ton. I gave you a ton of information, didn't I? Yeah? I want you to go away and practice. I have plenty of sheets for you, okay? Yes? And we'll practice. Okay? You work together. Can you imagine the quizzes we're going to have, like, you know, what's the principal quantum number for element 53? You know? What's the L quantum number for element 43? Right? Yes?
Yeah.
All right?
Yeah.
We're off.